All right. Hello. You can take your seats. Thanks for coming. No rush. We have 60 minutes. I have content for like 30, so you can like. Alrighty. Well, welcome. I hope you had a good time so far. This is my first time here in NDC. This is my first time in Oslo, in Norway. So thanks for bringing the nice weather. And yeah, I'm going to be talking about secret management today. Secret management the soft way, in fact, and why the soft way. So this is a Kubernetes talk. So if you don't use Kubernetes, my first question is why? The second question is, why are you still here? But if you do use Kubernetes, if you're familiar with it, maybe you've tried to look at the CKA, which is the Certified Kubernetes Administrator certification. You might have come across Kelsey Hightower's kind of like exercise thing called Kubernetes the hard way. And that's nice, but why does everything have to be like hard, right? Like why can't it be easy? Because we have all the content, we have all the resources here. So I want to talk about managing secrets on Kubernetes, but in like a not super hard way, in an easy way or a soft way. So again, thanks for coming. I'm really glad to be here. Really glad that we can all be in the same room again, that we can, like breathe on each other again. That's a really nice experience for me. And yeah, let's just like dive right in. A little bit about myself first. My name is Lian. I'm a developer advocate for Loft Labs. We build developer tooling on Kubernetes. We have a couple of open source projects that we maintain. I'm not going to be talking a lot about them. If we have a lot of time, maybe I'll show you a little bit. But basically, we're trying to make developing on Kubernetes a bit more like fun, maybe straightforward, especially if you have like a lot of different teams on the same Kubernetes cluster. And if you want to reach out to me, you can do that on the Bird app, also known as Twitter. You can send me an email. You can even find me on LinkedIn if that's really what you want, but I'm not on there a lot. In my previous life, I was a cloud native consultant. Well, before that, I was a software engineer. I was a web developer for a long time. And then I was a consultant helping customers to move into the cloud from their on-prem solutions. And yeah, in that time, I got a lot of insight into what ails companies, big organizations, people who are not that familiar with cloud native concepts when they move to the cloud and mainly Kubernetes. So yeah, a lot of what I'm going to show you today is kind of like based on that experience that I had as a consultant. So yeah, this is the crux of the matter, kind of like on Kubernetes, everyone knows your secrets. So since I have the time, I can go on a couple of tangents, maybe rant a little bit. So Kubernetes basically is a platform and an orchestration mechanism to run your workloads that are containerized. And it's not too super smart about it. It understands what a pod is. It understands that there's like, it has this reconciliation loop that it will try to always bring things to life. You can tell Kubernetes, I want these resources to exist on my cluster, and Kubernetes will constantly check whether your resources are alive, whether they're healthy, and if not, it will always try to bring it back. But it's not very smart about it. So there's a resource type on Kubernetes that's called secrets. But the thing is, it's not secret. If you have access to a Kubernetes cluster and you have access to look at resources, you can look at secrets and you can read the values, which means that they are not secret logically. So yeah, the problem is that everyone who has access to a cluster, has access to read secrets, has full access to it. So this is what a Kubernetes secret looks like. So if you're not familiar with Kubernetes, pretty much everything is a YAML. Every resource on Kubernetes is described as this like YAML structure. And here we have an example secret resource. You know it's a secret resource because of this like kind property. And yeah, there's some other properties like type and whatever. And then this interesting stuff here is data. And so in my example, I have like a username, password. It could be anything else. And then this here, like if you're familiar with this, maybe you can see that this is not actually encrypted. This is actually well, it's base 64 encoded. So I can just take this, copy it, paste it into a base 64 decoder, and then I know what it says. It says foobar, I think, or something. Or it says username, password, I think. So in the olden days, this was a fairly simple problem to solve. You would just not give devs access to the cluster, so they couldn't read them. Especially if you're on production, you probably don't want developers to read the production values of like username, password of a database or something. But recently, we have been told to do something called GitOps. How many people are familiar with GitOps? Just want to see what the penetration level of that is. Not super many. Okay, so in GitOps, the idea is, since you have Kubernetes and you can declare your state to Kubernetes through these YAML files, you can put these YAML files, these manifests, into a GitOps, into a Git repository like GitHub, and then use a mechanism to take these manifests and then send them to the Kubernetes API. And I'm not quite sure if no, I don't have a graphic for that, unfortunately. But the idea is basically that because you have all the manifests on your GitHub repository, and once you have it on or any kind of Git repository, you will have like an audit log, you will have some kind of like role-based access control, the one that Git brings you. So you have all these things that adds a separate security layer to your deployment process. So that's the general idea. So using GitOps gives you a lot of advantages, like you can deliver all your resources in one place. So all your resources, your pods, so your containers, your secrets, your infrastructure, whatever resources you want to have, like certificates, anything, you can put them all into this Git repository. And as I said before, you can have this built-in access control that is what Git gives you, or GitHub, or whatever. So you can protect branches and then only allow changes to the main branch through pull requests, for example, and then only deploy the main branch, and then you can do but fairly proper CI/CD. I mentioned that also you have the history of the state of your environment at any given time. Well, this is the desired state. You don't actually know whether this actually happened on your cluster unless you monitor the cluster also. Because as I said, it can happen that a pod can't spin up. Maybe you're out of memory or something. And you wouldn't know that from the front of it. So when you send a request to the Kubernetes API saying, please spin up this pod, unless you really check on the cluster what's happening with your pod, you won't know what state it is in, because the Kubernetes API will just tell you, all right, I've scheduled this pod. I told the individual components of Kubernetes, of the control plane, this is what you need to do, but I don't actually know whether this was successful. So you would have to additionally monitor the state of your cluster. So these are kind of the advantages. There is, so you can have this persistent history, but only as long as it works. So you can still, if you use Git you know that there is technically a way to always mess with the tree of a Git repository. There's things like reflog, and if you're an admin, a Git admin, you can always kind of mess about with it. But as I said, you can mitigate the risk of unauthorized history changes. For example, just not give people that much access to it. That's always in security. You should always not give people all access, just because it's a bit lazy. But instead, just give people the access that they actually need. On the downside, though, devs will have indirect or maybe even direct write access to this Git ops repository, because they have to somehow deliver their manifests into this Git repository, as long as you're doing DevOps. So the idea of DevOps is kind of okay, devs, they are responsible for the application and the source of the application, but at the same time, they're also responsible for how this application will run. So that's the ops part. And in the Kubernetes world, that would basically mean that they have to also write the manifests and understand a little bit what they're doing, for example, if they need some kind of resource limits or anything. So they will have to be able to write into this GitOps repository. maybe indirectly through some kind of like process, like CI/CD delivery pipeline or something, but somehow they probably will have write access, and that means they might have read access. Which means that if you put all your resources, including the secrets, into the same repository, then again, you're at this point where devs can read the secrets, and that's why I said, like, in the olden days, when devs did not have to like also deploy and deliver, that was maybe fine, but now that has changed. So I personally have a couple of opinions about whether DevOps is or isn't an anti-pattern. In this case, because we're doing DevOps, that means that we're breaking kind of the separation of duty because we have devs configure their applications as well. All right. So I want to take a step back and look at this a little bit more broadly, abstractly. So there's this thing called desire paths or desire lanes, and it's basically a path created by the erosion of when people or animals pass through the way that is most convenient for them. So I'm pretty sure you've seen that kind of like, there's like a path that's kind of like this, and there's always like a side path that's more the direct route because people are a bit lazy. And desire paths can also happen when your infrastructure is like super bad or super inconvenient. So on the left, for example, that path is clearly laid by like a blind bricklayer. So people will take, the path that is like more secure, maybe even. And on the right side, yes, obviously, if you do that, that's not very smart. So again, people, and especially I guess like bikers would probably just take like the easy way around it. And as you can see in these two pictures, the problem is, as soon as people use alternate paths, what will happen is it will weaken the overall structure of your product or organization and thus make everything less safe. And I'm sure you have like experiences like this as well. I know that I did when I was consulting for like a big banking IT, for example, that there were all these like super strict security guidelines. For example, the developers did not have access to all the code. If there was a bug, they could only see that part of the code that was broken, which we all know bugs only happen in one part of your application and never in like different places. So the software that they built, or the thing that they built around it, was that you get a ticket in Jira or something, and then you say, okay, you click on, okay, I want to fix this. It would then open, that was actually pretty smart, it would open your IDE, which I think was either Eclipse or IntelliJ, and it will automatically check out only that part of the code. Well, obviously it would check out the entire monolith of the code because it was a huge monolith, but then you could only like see like 2 or 3 files, I think, and only the ones that were described in the ticket. So because that obviously didn't work, what they did was they were hacking that application, so that application that kind of opened the IDE and the checkout and everything, which just broke everything. Apparently, somehow they made it work. They were still able to fix bugs, but it became extremely unsafe, insecure, because they were using like admin access to the repository, and that was just like not a great way to do things. Anyhow, so that was a tangent on like why desire paths are an important concept to understand. So if we really want to understand the developer's desire paths to find the right solution, we need to understand what are the main priorities of developers when they work with secrets. And this could be completely different for your organization. I'm just like showing you a couple of examples, or one scenario, and just thought of a couple of objectives that I would have if I was a developer working on Kubernetes, which I used to be. So the first main prime objective for me would be, I want to consume secrets consistently across environments. So this is something I've also seen in a lot of code, is that there's an if-else or something. Like, if we are on development, read the secret from this place. If we are on prod, read the secret from that place, and then maybe do this and maybe do that. That is not ideal, because the application itself, it shouldn't know where it lives. It should just always behave the same way. The way that you change how secrets are read or how secrets are delivered and provided should be happening outside the application. The second thing is that we want to keep the secrets out of the hand of developers. And it's not because we don't trust them. I mean, it depends on the developer. But people make mistakes. That can always happen. even with the best of intentions, someone might just accidentally delete, like a couple of namespaces, which happened to me, for example, or delete, a couple of database lines, which also happened to me, for example. So that can always happen, and as I said before, devs should always, or everyone should always have the least amount of access rights that they need. What we would also love to do is improve the developer experience working with secrets. That's just, the same thing about the desire path. Is it just super inconvenient or just like boring or whatever? Then devs will either not want to work with secrets anymore, and they will put things that are secret into plain text configuration, or I don't know, they will like come up with some other process and just like it might not be super safe. And then finally, I think this is finally, yes, I would love to use open source tools. I think open source is a great way to work together as a community, as an industry. But also I think that if you know exactly how the code works, or if you have like swarm, intelligence to figure out like, oh, these are the vulnerabilities of this particular tool, then once you know about it, you can mitigate it at other places in your application, in your organization, and then that will improve the trust and the security overall. All right. So as I said before, I have an example, so it's not too boring. So we will take a look at the setup. And what I want to end up is I want to have a secret in Kubernetes that kind of looks like this. It has a name, which is called test secret. I put it in a specific namespace. This is the namespace where my application will also live in. And I have these data properties. One is the environment, which in this case is def. I don't think it should be def. It should probably it doesn't matter. And then there's the source. So where does the secret come from? And in this case, it's from a YAML because this is a YAML file. And yeah, so we looked at this already. And this is a pod, so this is my workload. This is pretty straightforward. A pod can consist of one or more containers. In this case, this is just one container, has a name, it has an image, so I'm just running it on, I think, a Ubuntu BusyBox. And I will load into the environment the information from my secret. So I will write the stuff that's behind the key env, so this is this stuff over here, into the environment variable env, and I do the same with source. And then finally, I will echo the env and the source properties. So obviously, but I'm going to say it again, you should not be echoing your secrets into the container. This is just to show you that it works and that I'm, not lying to you. So don't do that. Okay, right, we looked at this. I forgot that I cut it out. Okay, so to do this, we have basically two options. So there's more than two options, but today I'm going to show you two options of how to get to this state in a secret-ish way. What we could do is we can encrypt our secrets before we deliver them. So we encrypt the secrets first and then put them into our GitOps repository. To do that, I'm going to use a tool called sealed secrets. And the good thing about that is if I have access to the GitOps repository, I still don't know what the content of the secret is because they are encrypted. The alternative is I can deliver only a reference to the secrets, but I have the secrets somewhere else. And the way that I'm going to do that is I'm going to use a tool called HashiCorp Vault. The Vault will store all my secrets, and then I will use another tool called the external secrets operator that will be able to grab my secret out of Vault and then put them into my Kubernetes cluster. And I'm going to explain more in depth how that actually works. All of these are open source tools, by the way. All right, so we will look at the first option where we're going to use the sealed secrets. In this scenario, we have three components to our system. We might have more, we might have less, but right now I'm just talking about these three because they're the most important ones. This these two, the cluster and the repository, I'm just going to say these are the responsibility of the ops team. That's why the line is like, it's a through line. And this like dashed line is in the responsibility of the developer. So yeah, this is, for example, the dev machine. So it would be your laptop, for example. The reason why I separated those two into like two responsibilities is because, well, first of all, we work mainly with like platform teams, so like ops teams, as they would used to be called. And I think it's important to understand that what we want is for the devs to have a very simple, very safe environment, and the ops team to really, do all the shitty stuff. For them to have the responsibility, because they should understand, well, out of the two, the ops people should be the ones who understand the cluster and how it works. So we start with the sealed secrets operator. And again, if you're not too familiar with operators, they are controllers pretty much that live on the Kubernetes cluster and make use of this reconciliation loop that I talked before. So what this operator is doing, first, when we install it, it will create a private and public key pair, and we will use these later to and decrypt our secrets. What we need to do is, well, the developer needs to grab that public key from the cluster and then use that key to encrypt the Kubernetes secret to then get a sealed secret. And we will, so we can take a look at the sealed secret now. So it looks very similar to the secret that we looked at before. There's a name, there's a spec. The kind is now sealed secret because it's a specific custom resource type. And what we can see here is, instead of just data, it has this field called encrypted data. And I'm sure I cut that out again. So in here, this is actually encrypted. We still have env and source, so the property names are the same. But this is actually now encrypted data that you cannot read, even if you have access to this resource definition, or even if you have access to the public key, because the only way to decrypt this is with the private key, and the private key lives on the cluster. The other thing is that we can also give it like this template metadata name, so we can change the name of the secret that we want to create out of this sealed secret, but that's just an aside. So now that we have the sealed secret, we can move that to the GitOps repository, and the mechanism that installs things from the GitOps repository to the cluster, whatever that is, it might be Argo CD or Flux or whatever, maybe it's just a Jenkins, that will then deploy the sealed secrets to the cluster. And now the sealed secrets operator, that will constantly monitor on the cluster whether there are any resources of type sealed secrets, and if there's any like change in the state of any sealed secret, it will do whatever is appropriate to do. This is basically a state machine. It will look for sealed secrets, see if there's a change in state, then I'm going to do these things. And if it sees that there's a sealed secret, it will take the private key, it will then decrypt the sealed secret, make a Kubernetes secret out of it, and that's it. Okay. Oh, sorry. I thought there would be more. Okay, so I'm going to show you a demo. And let's see. All right, I have to probably. Okay. So this repository is also on GitHub. So you can check it out later for yourself if you want to. So what I have is, I'm using vCluster, which is a tool that we use, which provides me with a bunch of virtual clusters on my local machine. And the nice thing about it is that I can simulate multiple clusters on my local machine, and they're very lightweight, and I can pause them later and everything. And I don't have to use like a bunch of stuff, or have to go to like online clusters. All right, so I have a running Kubernetes cluster now. I have not much installed besides I have the sealed secrets controller. And what I'm gonna do next, let me also see if I deleted my namespace. Yes, I did. Okay, so I will cheat and look at the README here because I don't remember what I actually need to do. Okay, so I have the sealed secrets controller installed. What I want to do next is I want to now fetch that public certificate, the public key from the cluster to be able to encrypt my Kubernetes secret. I'm just going to make this a little bit bigger. And the way that I do that, I need to use this this utility called kubeseal. You can download it, and then I will execute this command, which is like fetch certificate. I need to tell it where the controller lives, which is on default, as we can see here, and then I write it into this pubcert.pem. So if I look at that now, this is what it looks like. It's a public key, so it's not a big deal if you see it. I just now realized that I'm in the wrong folder. Okay, let me just do this again. All right. Okay, so the next thing, now I have gotten that public key, so now what I want to do next is I want to use that key to now seal my secret. So I have this secret, it's called prod.kate's secret. This is what it looks like. So again, it's prod and YAML, and this is already base 64 encoded because it's a Kubernetes secret. That's what I need to do. So I can use kubeseal again, and I tell it use this certificate over here, pubcert.pem, and I want to now make this prod.kate. I want to seal this prod.kate secret into something called sealed secrets and put it out in a YAML format because the standard format would be JSON. So now that I've done that, if we look at the sealed secret, this is what it looks like. So now I have this name over here. The namespace is already there because that's what it already said in the original secret. And now I have this encrypted data. So now my secret is actually encrypted, it's sealed. And I can now, I'm going to create my namespace. And then I'm going to apply this sealed secret. YAML. Okay, so it's there. I can maybe look if it's already isn't there. Okay, so I can see that I have a sealed secret in the namespace sealed secret app, and what I should also be able to see now is that I should have this test secret that is not a sealed secret, it's a Kubernetes secret that magically appeared. So so I just want to take a closer look. And what we can see here is we are back. We have this information again that we started out with. And we can also see that the owner reference is the sealed secret controller. So this is the proof that we didn't create the secret, but the sealed secret controller created the secret. And if I want to just like really kick it up a notch, I can also now deploy that pod that I was talking about earlier. And we can look at that pod. Oh, I can't use -a. That's a pity. Okay, so it successfully echoed the values behind env and source. So that means we also successfully were able to mount the secret into the environment. So this is all very nice and dandy. The thing is, though, maybe you've already realized that the problem is that if we do it this way, that means that our devs, they start with the same secret that they end up with. So it's kind of like, you know, it just feels like the same thing, but like a bunch more steps. So if you do it on development, you can do it this way. If you want development and production to be the exact same, so the developer would go to the development cluster that they have, and then seal the secrets themselves, put it on a repository, whatever. On production, you probably wouldn't want the developer to actually do that. You for sure wouldn't want the developer to do that. On production, you would probably have some kind of automated system. So you would have, let's say you're using database password, username, password, and then the database team will create the credentials for it, and then you would want to have some kind of automated system to seal those credentials instead of the dev doing it by themselves, which makes sense because you want the devs to like not have access to these secrets. So I see you totally understand what I was just talking about for the last half hour. Okay. If you have any questions, please ask later. Okay, so in summary, what you have to do when you use sealed secrets is that you need to manage your secrets separately. So you can't manage the secrets on Kubernetes, or you shouldn't be managing them on Git at all. You need to like lifecycle management, all those things. You need to do that somewhere else, and then encrypt the secrets, and then put them on GitOps. What you can do is you can deliver the secrets with the rest of the resources in the GitOps repository, which I think is really great because everything is there, right? You don't have some kind of reference to something else that you don't know about and you can look into, but you just know exactly what's in the repository is the stuff that you are deploying to the cluster. The other thing is that this pub key, this certificate with which we've sealed the secret, it can be shared with other developers, so you don't even have to have the developer go to the cluster. As you saw, I can just use the kubectl command and I actually expect the certificate to be somewhere on my hard drive, for example. So you can completely remove access to the cluster from the developers, and they still be able to seal the secrets. Don't share the private key, by the way, goes without saying. That's the next point. Because the key pair is recreated every time you install the sealed secrets controller on a cluster, if I want to do that for development, test, production, I need to seal the secret every single time. I need to seal it with the key pair from each cluster. One of the clients I worked with, they were like, oh wait, why don't we just like take that private key from cluster prod and just put it on cluster test, because then I don't have to reseal it. But then it was like, well, if you do that, then there's no point of having a private key. If you're removing it from the cluster, you're breaking all the security guidelines, and then you can just, it doesn't matter, then you can just do whatever. So you need to reseal the secret for every environment that you want to use it for. Okay, so this was example number one, which is to encrypt before delivering. And then this other example is only deliver the reference to the secret and have the secret somewhere else. So we start with an architecture which is a bit similar to what we saw before, except we also now have HashiCorp Vault. And in Vault, we have an entry, and that entry is our secret right now. And on the Kubernetes cluster, it is kind of similar to what we saw before. We have this external secrets operator now, which the operator functions in a very similar way. It will always like use this reconciliation loop again. But what it also has is a service account. So on Kubernetes, technical users that automate things and they need some kind of authorization, they're called service accounts. And the service account is tied to this controller, this operator. And what we have to do is we have to tie the service account to a specific role and policy within Vault so that the service account that's tied to the operator is allowed to read that entry. And you can make that very granular. You can say that the service account is only allowed to read this one single entry. That's really nice. What you also need is something called a secret store. And the secret store basically just tells the operator where to go, which service account to use, where to find the role and the policy and so on. So that's just a bunch of information. And what's nice about this is if I have, instead of Vault, maybe I'll be using, I don't know, GCP account manager or something, or secrets, I'm not quite sure how it's called. Or there's something on AWS we can store secrets, and there's a bunch of them. all you have to do is replace that secret store with another one. And the rest can stay exactly the same, because for the external secrets operator, it doesn't matter whether you're getting your secrets from Vault or from anywhere else. So let's look at the secret store, because that's actually quite interesting. So again, we have a custom resource, which is called secret store. And we have a name. It's called Vault backend, because it's using Vault. And here we basically tell it, the provider we're using is called Vault. And this is where you can find it. So this is the URL, this is the path, version, whatever. And here we're telling it, listen, there is we're using Kubernetes auth here. And you can find that in this path, and the role that you're supposed to use is called ISO role. Oh yeah, forgot about that again. And then what we do is on the development machine, we have something called an external secret. And that is not the actual secret, that is just a reference to the secret, and we can just put that onto the GitOps repository. But I'm going to first show you. This is what the external secret looks like. Again, custom Kubernetes resource has a name, putting it in a specific namespace. Again, this namespace is where our application will live later on as well. And here, this is the thing that I was talking about earlier. We tell it, this is the secret store that you're supposed to use. It's called Vault backend. And we can we just have to replace this secret store reference with another one if we decide to one day replace Vault with something else. And that's it. That's really nice, because we don't have to change a bunch of stuff. Basically, just have to change that stuff, and the rest can stay exactly the same, because what we're doing now is we're telling it, okay, once you find that secret, create a Kubernetes secret by name test secret, and these are the properties of the secret, and please map the secret from Vault to these properties in the Kubernetes secret. Okay. And then, as I said, you just put that external secret into the GitOps repo with your other resources, and then whatever mechanism you're using to deploy will pick that up and put it into the cluster, where the external secrets operator will monitor for changes of external secret resources. Once it detects a change, it will then go connect with the service account, go to the secret store, check out which role and policy it needs to assume, take the entry in Vault, hopefully, if you set up everything correctly, and then create a Kubernetes secret out of this. Okay, demo time. So, let's see. Okay, so I have to first, because I was sleeping this one, resume. Okay, and then I need to connect to this as well. So now on this one, wait, I have to wait for it to come up. Okay, I have already pre-installed the HashiCorp Vault on the cluster and the external secrets operator. The reason why I installed Vault on Kubernetes as well is just because it's easier to do that instead of having a separate Vault instance somewhere on the internet or anything. So what you can see is I have Vault. The Vault uses a console backend here. These all live in the namespace Vault, and then I have this external secrets operator that lives on ISO. And what I'm going to do now, I am going to show you this. I think what I have to do first is I have to export, and I have to port forward the Vault so I can just talk to it directly. Yeah. And then, okay. All right, so I have to now use, have you ever used Vault before? You can interact with the Vault CLI pretty easily with the token that you have to give it once. And then you can just use the CLI to just talk to Vault. Oh, wait, that was stupid. Export. Yeah. Okay. Oh, shit. Okay. I don't want to, this is going to take a while because I have to now unseal. Someone want to hear a joke in the meantime, or like tell a joke in the meantime? Okay. Operator and so I can only see half of my screen. That's really unfortunate. Okay. So the thing about Vault is you need to unseal it 3 times because the threshold is set to 3 right now. And I thought I had sealed it, but unsealed it, but apparently it will just seal after some time, which is probably good. Okay, so it's now unsealed. Can I just log in again? Does that work? Okay, perfect. All right, so what I'm going to do is I have to create this entry in Vault first. So I'm a developer right now, and I have to create this entry, which is again, env prod, and source is now Vault, because now we're reading it from HashiCorp Vault instead of a YAML. So we're doing this now. This is version 3 because I created it a couple times already. And I don't actually know if you can delete stuff from Vault. You can delete it, but it's never really deleted. It's just like, I don't know, just disappears. Or like you can't access it anymore, but it's still there. So what I need to do next is I need to create a namespace, and I need to actually go into my correct folder. And here I have the external secret. I'm going to show it to you. This is what it looks like. Really need a mouse for this. Okay. So it's very much like what I showed you before. So I have this reference here to the secret store, and I basically have these explain how I want the entry from Vault to be mapped onto a Kubernetes secret. So I'm going to apply this external secret to my cluster. And then if I look at secrets, I should be able to see this test secret that was created 7 seconds ago, which was not by me, because I only created external secret. And then I'm going to show you again, I'm going to do the log of this pod that I created. Yeah, sure, why not? Oh. All right, so here we now see the logs with source Vault because we've read it from Vault. And if we look at the secret specifically, over here, yeah, so here we have, again, this owner reference that tells us that the owner is the external secret and not us, or it would probably be empty, actually, if we just created that secret by ourselves manually. So that was, I mean, okay, so first of all, live demo worked. Thank you, demo gods. That was great. This was like, I'm done. No, just like to summarize, if we work with Vault and External Secrets Operator, the nice thing is that the External Secrets Operator works with many providers. So we can put our secrets in Vault. We can put it in, as I said, GCP, AWS, Azure, what have you. It doesn't even have to be one of the cloud vendors where you run your Kubernetes instance, if you have one, but you can just put it, I don't know, somewhere completely else. As long as you can access it through the External Secrets Operator, you can run it. If you can't access it yet, as I said, it's open source, so feel free to go in and contribute to it. That would be great. I'm sure the people would be super happy about it. And the thing about this now is that you have a way to manage secrets. You can manage your secrets with Vault, and it's fairly safe for dev teams. Dev teams can even create secrets that they don't know. They only know what it's called. They know the properties, how they can access it, but they don't know the actual value. So that's actually super handy if you want to create database credentials or something like that. Because you're using something like Vault, you already have the built-in security best practices in there. For example, rotating keys and the entire life cycle of things you have in there. It's fairly secure. Again, security is not just the technology you use, but also the practices that you have. So nothing's 100% secure ever, but it's definitely already better than just storing your secrets, I don't know, on your post-it note or something. The downside, if you want to call it that, is that this setup is quite elaborate. So before the sealed secrets controller, it was just one controller, and that's all you needed. But here you need to have the vault, you need to have the ESO. You might want to have a separate team that manages Vault. So it's nothing that I would recommend for you to do if you're just 2 people, unless security is your product, then maybe do it. But if you're just at the moment where you're just doing POCs, discovering things, maybe sealing your secrets is enough for that first step. So in conclusion, you can go to the GitHub repository that I showed you the demo for, and you can try it out for yourself. And I promise that this does not lead to a Rickroll. So this QR code leads to that repository. So if you want to take a picture, you can do that right now. I'm probably also going to put it on Twitter or something later. So I just want to wrap up to talk about what we did solve and what we didn't solve, because this is, as I said, this is 2 examples of how you can do this, but there's a bunch more. We have now secured a little bit, kind of, the supply chain, but at the end, on the cluster, we still end up with that Kubernetes secret that everyone can read. So it only works if you don't give your dev access to clusters that they shouldn't have access to. There's other things you could do. For example, you could write your application in a way that it reads the secrets directly from Vault instead of putting the secrets on the cluster. That's a way that you could do it. But then again, you have the whole secret management stuff in your application. You might not want to do that. With Kubernetes, you can do things like have sidecars. So you can have one pod with multiple containers. You could use one container to just read secrets and put them into the container that then runs the application. Maybe. That depends on how your organization works, how you do platform stuff. You can talk to me about it later if you want to, but yeah, I'm not going to tell you what to do. I don't know what's the best idea for your organization. So as I said, yeah, the Kubernetes secrets are still unencrypted. You still need to secure the cluster, right? Just because the supply chain is secure does not mean that your cluster is secure. So every security talk always ever remember that you need to secure your cluster for malicious injections, for container breakouts, all those things. So one thing about Kubernetes that I think is super important to understand is that Kubernetes does not understand secrets. So Kubernetes is basically like this manager who's saying, first, I've decided we need an SQL database. Second, I need you to tell me what an SQL database is. So Kubernetes can manage resources, but it doesn't understand that this secret resource is a secret. It just knows, oh, it's a type secret, so the data that's in there is base64 encoded, and I need to decode it and then feed it to the pod that wants to read it. But it's not able to manage secrets. It doesn't do secret lifecycle or anything like that. You have to do this yourself outside of Kubernetes. And I personally think it's good because I don't want Kubernetes to do everything. That's surefire way for it to be crap at everything. And yeah, finally, as I talked about before, desire paths, they exist. There's nothing you can do about it. That's just human nature or just animal nature. But what you can do is you can try and understand what the desire paths are and then build your system on top of that. So if you have devs that want to work with Vault, then try and build that into your platform, or try and change the processes in a way that it will accommodate that. Because people are going to do what people are going to do. There's nothing you can do about it. The only thing is that you can try and build your system in a way that will accommodate that and not break the security of your application. And that was it. And I think we have 10 minutes for questions. If you have any, thanks for listening. Any questions? No. It's time for lunch also, right? So everyone's. Oh, there's a question.
Do you have any advice for secret rotation on Kubernetes?
Do I have any advice for secret rotation on Kubernetes? Yeah, as I said before, you probably want to do that somewhere else. So what I definitely think is you manage your secrets somewhere else, and then you put them into your Kubernetes cluster. Do you do CI/CD? Yeah. Yeah. Okay. So if you do CI/CD, and if you are using the same delivery process for your application as you do with your secrets, then you manage your secrets somewhere, rotate them, and then put them into your delivery process, and that is a change just as any other changes. So that would be a deployment just as other deployment. Every other deployment that you do is when you change the secrets. That's one way to do it. If you have separate delivery processes, for example, what I've also seen is that developers have their delivery, and then everything the ops team does, including secrets, they have another delivery process. That's also a way that you could do it. They still use GitOps. They still use, I think, Argo CD, but it's just a different pipeline pretty much. But I would recommend for you to use a tool like HashiCorp Vault to rotate the secrets and then deliver them just as you would deliver any other resource. Does that answer your question?
Yeah.
Good. Any other? Yes.
A question regarding this authentication towards the vault itself, because it was mentioned this token
Uh-huh.
from developer machine towards the vault.
Yeah.
So, and isn't that so that in this case we again step on the secret, which is, let's say, from developer point of view, something that should be protected, because then it ends up on his dev
You-
workstation.
Yes. So do you mean that when the developer is creating this entry, is that what you're saying?
You were showing actually there was the token. You said it should be submitted once, or because you need somehow to authenticate towards from developer.
Oh, okay. I see what you're saying. You mean when I was showing you this demo and I was logging in with and then I logged into this and I have to do it once. This is not how you should do it because this is an admin token. So because this is my development environment, I can do that because no one else has access to it, and I'm not going to break production if I just log in as an admin. But if you're using Vault, everyone gets their own token for their user account. And your user account is very restricted. Like you can have access to only one secret or one entry and only to read it, for example. So that's how you kind of have that security built in. So because you only have read access to this one secret, you cannot break any other secrets. Or maybe you have write access to one secret because that's the secret that you write to. There's one thing you can do, as I said before, you could put a secret, and you can't do that with KV, I think, but there is another type of entry that you can do with a Vault, where you basically create a secret, and you say it should have env and source, but you don't actually know what the values are. So you can actually create secrets and change them. Well, I don't know how much you can change them, but you don't actually know the values, so that is kind of a security layer that Vault gives you. It might be a plugin. I'm not quite sure if Vault itself can do that, but I mean, I would need to check the documentation for that. Does that answer your question?
Thank you.
Okay, cool. Any more? Yes.
Can a secret reference another secret? So, for example, if a database admin adds a database secret password connection string, and I can reference that. I don't know what's in it, but I can reference that other secret.
So can a secret reference another secret? What is the secret that I'm referencing? That's in a database or something?
No, the database administrator
Uh-huh.
comes in and he adds a secret for a database or say
Yeah.
a cluster message clustering.
Yeah.
And I don't know what that message clustering is, but I use that for 5, 6 different services, and I want all of them to reference the same cluster. So
Gotcha.
and I could also want to reference different clusters. So I don't want to reference that specific cluster. I just want to reference a secret and then reference. Oh,
Yes.
Now I'm referencing this, and later I'm gonna change and reference this.
So if I understand you correctly, you basically have a secret that has the credentials to another secret. I think, yeah, you could do it, but you probably need some kind of compute to read that and then do what you want with it. So you could conceivably run a container that takes those secrets and then use them to now call this other thing and log in there. So you definitely can do that, because it doesn't really matter what you do with it, right? You could do anything with the secret, and then you could build a chain, but you need some kind of workload to do that for you. So yeah, for sure. We could write a controller for it, or an operator, if you want to. Yeah. Any more questions? Yes, the gentleman over. Okay.
With the sealed secrets,
Yes.
also include kind of automation to fetching the public key? Because like if you have the dev staging prod, it's easy enough, but you have kind of tens of clusters or something like that, and
Yeah. So the question was, if I understand you correctly, is there a way to automate sealing secrets? Because if you have a bunch of them, yeah, that's why sealed secrets are maybe not ideal if you have, like, let's say 100 clusters, because then you have to, like, if you have, let's say, 100 clusters for each environment, and you have like 3 different environments, dev, test, and prod, then you would have to do it 300 times. I mean, it is a CLI command. So you could just write a script that does that, right? That is automated. You can automate it. Is there something that already exists? I don't know, but it doesn't seem too hard to just build something, like just write a script that does that. But I don't think it's a super great idea if you are on that scale to still seal your secrets. It kind of depends on, again, what your use case is. But yeah, you could definitely automate it.
but yeah, that's what I was asking, that it's not a good idea then.
Yeah, I don't think it's a great idea, because I think this solution is not meant. I mean, you can do it. I'm pretty sure that if you ask if you ask Bitnami, they would tell you, yes, you should do that. But I personally think that if you have so many clusters, you need to look at your system holistically and think about, is it still safe to seal every single secret with every single key? Or would it be more useful to use something that's more centralized, like Vault? But yeah, again, I can't answer it 100% for your organization, but I personally wouldn't do it with sealed secrets.
The same set of keys on multiple clusters. For example, for all the dev clusters, you could use the same set of keys, because nobody cares about the secrets maybe on the dev clusters, but it will make it easy.
Yes. So you could use the same keys for multiple clusters, but I wouldn't recommend that, because once you remove the key from the cluster, it's kind of not safe anymore. Then you're breaking that security level of. That's exactly what sealed secrets does, is because you have the private key only on the cluster, that's what makes it safe. That's why you cannot decrypt a secret outside of the cluster. But once you remove it, there's no telling what's happening, and like it could be anywhere. So then it's kind of just breaking the point of using sealed secrets. But you can do it. If it's for dev, I wouldn't mind it that much, because it's dev, right? Like these environments are often very ephemeral, so you just do it. What we also try to do is when we set up dev clusters, like feature environments, for example, we would feed it that private key already. So you didn't even have to set it up. We would just always give you the same private key, just to make things easier, just because so the automation would always be the same. But we only did that for dev, because, yeah, risks and everything. Okay, I think you had one question. Yeah.
You showed that the way that the dev can deploy a pod using that secret. But how the dev would, for example, debugging, use some tool?
So the dev can deploy a pod.
Yeah, but no, I mean, for example, we're using Lian, for example, Visual Studio. He is debugging, and he needs to access the database secrets.
Uh-huh.
How would the dev do it?
So a dev needs to debug something where it uses a database for. Yeah. And then what's the, I don't really understand the problem, I think. Can you explain it a bit more?
For example, the code would get the scope, the secret,
Uh-huh.
because it's on the Kubernetes cluster.
Yes.
The secret. How is it possible to the dev have?
Oh, so the dev, if you're not on a Kubernetes cluster, how do you have access to that secret? Okay. So again, it depends on kind of how you do development. So one thing you can do, you can just develop on a Kubernetes cluster. There's ways to do that. One of the tools that we work on, for example, DevSpace, allows you to change code in your work machine, and that will, you have a local Kubernetes cluster running, just as I have like Docker Desktop running, and I have my virtual clusters on it, but it doesn't matter really it could just be on Docker Desktop. And then this is also something that you can check out in the repository, by the way. I'm using this dev space tool, and what it does, it will deploy a container to this local cluster, and if I change something in the code, it will hot load that code. It will mount these changes into the running container, so I don't need to redeploy it, I don't need to rebuild the image. It will just mount the changes directly into the container, and I can work on my code and debug and do everything while it's running on a cluster. But to me, it doesn't feel that way, because to me, I'm just changing code directly on my host machine. That's one way to do it. The other thing is, of course, you could connect to, it depends on, if you have let's say the database lives on some cluster in the internet, or in the intranet, if you're like on the, the reason why you would want to do it this way, where you have separate secrets on prod and on dev, is so you can read the dev secrets, but you cannot read the prod secrets. So you would have maybe the credentials to the development database, but you don't have the credentials to develop to the prod database. But your application doesn't know that there's a difference, because to the application, it always looks the same. So if you're, for example, mounting them into the environment, you would just mount your development credentials into the environment, just as you would in a container. But yeah, so if you're working with Kubernetes, I think the trend is to work on Kubernetes already on your local machine through tools like DevSpace or Tilt or Gitpod. There's a Scaffold. There's a bunch of them now, just so you don't have that big difference between what's happening on your local machine and you made all the changes and then you want to deploy it and then you see, oh, fuck, that doesn't work because now I'm in a container. Yeah. Thanks. Any more questions? No, we're hungry. We want to go to lunch. Okay, thank you so much. Thanks for all the questions. Have a great day.